So let's get started. Today we are going to talk about new chapter, which is force system resultants. And the first point we want to talk about it here, we are going to talk about something called a moment of a force. And it's a crucial concept. We are going to find it a lot here in that course, and also in the advanced courses you are going to deal with the moment of a force. So today make sure that you totally understand what does it mean by a moment of a force. So you may have an idea about it in physics 101, but today we are going to make sure that you totally understand the moment of a force, and also are going to build on that information in the next lectures. So in order to understand this, we know the carpenters. The carpenters use a hammer a lot, especially this part here, in order to pull a nail. So sometimes we have a stubborn nail, which is located here, and it's very difficult to pull it out. So the carpenters use the hammers. So if you use a hammer here in order to take out a nail, then you are going only to apply a force in this direction. So even though I only apply a force in that direction, but as a result, the hammer is going to rotate about a point O. So I'm going to have a rotate like this one, rotate which is clockwise here. And as a result, that rotation is going to take out that stubborn nail. And we want to understand what sort of actions does that force here. So the force is going to get a reaction, or is going to have rotation. We want to understand what that kind of action and what is the force has to do with that. And that rotation, as a result of that force, we call it a torque sometimes, and normally we are going to call it a moment of a force, because we are going to have a rotation, tendency for rotation as a result of that force, or sometimes we are going to simply call it a moment. So again, we know that the force is we used to have the scalar and the vector, and we know that the force is a vector. And since it's a vector, it means that it has magnitude and direction. And the same goes for the rotation tendency as a result of the force. We say that it has direction, which is the clockwise, and of course is going to have a magnitude. So the moment also is going to have magnitude, and also is going to have a direction. But today we are going to focus on the scalar formulation only, not about the vector. Next time we are going to study the moment of a force in vector perspective. So when we say a moment of a force, it means when I apply a force. So here I have wrench, and I apply a force to the handle of the wrench. So when I apply a force to a body, so the wrench here is a body, that force is going to produce a tendency for the body to rotate. So that body here, as a result of that force, will try to rotate counterclockwise as a result of that force. And we call this a moment of the force. But the line of action here, you see here, you see the line of the action. If that line of action it was here, then you are not going to have a moment of a force. So we have a condition for that. As long as we have the force, if we draw a line parallel to that force, we call this a line of action. If we draw the extension of that line, it's the line of action. So as long as the line of action does not go through the point of rotation, in that case, we are not going to have a moment of a force. So when a force is applied to a body, it will produce a tendency for a body to rotate about that point. And we have condition, the point is not that on the line of action of the force. So if I draw the line of action here, it's not acting on the rotation point. If the force was here, in that direction, then the line of action is going to pass through the point of rotation. And as a result, we are not going to have a rotation. So if you are holding a wrench and you applying force in that direction, the nail, the bolt here is not going to rotate. Like I said, we call this tendency a torque, but most often it's called the moment of a force or simply the moment. So here I have the wrench, and we are going to apply a force at the handle of the wrench. And then as a result, we are going to have a rotation about the bolt. The bolt is going to rotate as a result of that force. And we said that we call this a moment of a force. So now we need to understand the magnitude of that rotation. So in order to do that, we find out that if we increase the force here, the rotation is going to be increased. Also, if I increase that distance here, which is perpendicular to the line of action of the force, also the amount or the magnitude of the moment is going to increase. So we can say that the magnitude of that moment is directly proportional to the magnitude of the force, and it's perpendicular, and it's also proportional to the perpendicular distance here. So the magnitude of the moment, it depends on the magnitude of the force and the distance, perpendicular distance. And if the force is not making 90 degree, so here if I draw the angle here, I'm going to call it theta, the angle here is 90. Then if the angle here is not 90, what do you think will happen to the amount of the moment? We said that the amount of the moment is proportional to the force and the perpendicular distance. If the force here is not making 90 degree, that means the distance here is not longer a perpendicular distance. The perpendicular distance is going to be here. And in order to calculate that distance, the distance is going to equal d times sine theta. And we know that sine theta, it cannot be more than 1, which means that the length here is going to be shorter. And if the length is shorter, that means the amount of the moment is going to be smaller, because we decrease the perpendicular distance. And you may ask how I know this distance is perpendicular. If I draw the line of action here, for example, let's say that distance here is the perpendicular distance. So that it will be wrong because the distance here is going to be longer than the distance here. So the perpendicular distance is the shortest distance from the that point to that point. What if I apply the force that the line of action is going to pass through the point of rotation like this one? Well, I'm going to have a moment? Of course not, because here I don't have any perpendicular distance. So if the line of action is going to pass through the point of rotation, in that case, we are not going to have any moment. So in order to have a moment, I need to have perpendicular distance. So assume that I have a body here and I apply a force, and that distance is the perpendicular distance. As a result, I'm going to have a moment about that axis, which means that I'm going to have rotation about that axis. And in order to know the direction of the moment and the axis of the moment, I'm going to apply the right-hand rule. And it's important to apply this when we are dealing with the a moment in a vector form. So the moment O naught about the point O, we have a moment about point O, or about the axis passing through the O. We have axis here perpendicular to that plane passing through the O here, and it's perpendicular to that plane. It's a vector quantity. Then we are going to have a vector quantity. And in the beginning of the lecture, I say that the moment it's a vector. It's similar to the force. Then is going the moment. We are going to have magnitude. Also we are going to have direction. So the moment here it has direction and it has magnitude. We need to calculate the moment, the magnitude of that moment. We said that the magnitude of the moment is proportional to the force and it's proportional to the perpendicular lengths. So we are going to say that the magnitude of MO equals the force times the distance. The perpendicular distance, we call that the moment arm or perpendicular distance from the axis at the point O to the line of action of the force. So this one here is the distance from the axis here to the line of the action. And about the unit of the moment, since it's force time a distance, then we are going to have Newton meter or pound foot. And also we need to know about the direction. See, the direction of M naught is defined by its moment axis. I need to know the moment axis first. And in that case, it's perpendicular to the plane. So it's very important to, in order to know the direction of the moment, I need to know the moment axis. Then it's going to be clockwise or counterclockwise or anti-clockwise. If we are going to deal with 2D, so if we are looking from the top, then we are dealing with 2D problem. In that case, the direction either to be clockwise or counterclockwise. It depends on the tendency of the rotation. So if that force was in the opposite direction, then I'm going to have a moment which is in the clockwise direction. So dealing with moment is very simple in 2D. If we want to calculate the moment is going to equal the force times the perpendicular distance. And the direction is going to be either clockwise or anti-clockwise. And it's very important to identify the perpendicular distance. Once you know the perpendicular distance, then the problem is going to be easy. And sometimes when I have a body, I'm going to have more than one force. Like we learned previously, I could have F1, F2, and F3. And in that case, as a result, since I have D1, D2, D3, I'm going to have three moments. So I'm going to have moment 1 as a result of F1, D1, and I'm going to have a moment as a result of F2, D2, and I'm going to have a moment as a result of F3, D3. And if I apply the force in that direction, the moment is going to be counterclockwise. In that case, since the force in that direction, the moment is going to be clockwise. And in that case, since the moment, the force is in that direction, the moment is going to be counterclockwise. So how I'm going to deal with system like that? Then, if this the case, I'm going to say that the MR, the moment resultant, as of this all these forces and moments, equals the summation of the force times the distance, or the summation of the moments here. And I need to put the a sign for the direction. Here in this course, we are going to assume that the force which is counterclockwise is positive, and the force which is or the moment which is clockwise is going to be negative. We are going to use this sign convention in order to deal with the resultant moment. So in this textbook, we are going to use that sign convention. If the direction of the moment is counterclockwise, we are going to put positive. If the moment is clockwise, it's going to be negative. So in this case, since that moment is going to be counterclockwise, it's going to be positive. So we're going to have F1 D1. Regarding M2, since the direction is going to be clockwise, then it's going to be negative. So we are going to have minus F2 D2, and the last one here, the sense here is positive since the direction is counterclockwise. So we are going to have positive or plus F3D3. So whenever I have a system of a moment, I need to use the sign convention in order to deal with the summation of the moments. So now I'm going to show you examples in order to understand the idea completely. So now we have example 1. In example 1, we need to determine the moment of a force about point O. So here I have a point O, I have a body here, and I apply a force equal 100 Newton. So we have 100 Newton at the end of that body, and the distance here is 2 meters. I need to know the moment about O. So of course, the axis of the moment is going to be perpendicular to the screen here, and the direction, since the force is here, imagine that you apply the force, and as a result, that bar moved here. That means the rotation is going to be in this direction, which is clockwise. So now we need to calculate the moment about that point. We said that the magnitude of the moment is the force times the perpendicular distance. To know the perpendicular distance, I need to draw the line of action. So the line of action is here. And then draw perpendicular line from the point O. So I'm going to draw a perpendicular line here. It's going to make 90 degrees. Then the distance from here to here is the perpendicular distance. Then I'm going to say the moment here is going to equal 100 times 2, which is perpendicular distance, and the direction is like that. Okay, so the moment is going to equal 100, which is the force, times the perpendicular distance, which is 2 meters. And the answer came out to be 200 Newton meter, and the direction is like that. It's very important to put the direction of the moment. Now let's move to example 2. So also we need to determine the moment of a force about the point O. So this time the body is like that. We apply a force here, and we need to know the magnitude of the force. Again, the moment equals the force applied times the perpendicular distance. The trick is to find that perpendicular distance. I said that first draw the line of action. So this one here is the line of action. Then draw perpendicular distance to the line of action. So if you draw from here to here, is that the perpendicular distance? No, because this one here is not the shortest distance. The shortest distance is going to be from here to here. So I'm going to say that the distance from here to here represent the perpendicular distance d, the moment arm. And here I have the force. So in order to know the direction, I'm going to imagine that I apply a force here, and as a result, the body move from here to here, which means that the rotation is going to be clockwise. So in that problem, the moment is going to equal 50, the force, times the perpendicular distance, which is 0.75. The distance here is the same as the distance there. So if you don't understand the perpendicular distance, you might say that D is the perpendicular distance, which is not. Let's move to example 3. In example 3, we want to determine the moment of the force about the point O. So here is the point O. We apply a force at the end of that body. This time the body is just like that. We apply the force here, and we want to know the moment about the point O. So again, I'm going to draw the line of action here. Then I'm gonna draw a line from the point O, which is perpendicular to the line of action. So this one is here, and this one represent the perpendicular distance. Again, the perpendicular distance cannot be here or cannot be here because it's the shortest distance. So the perpendicular distance is going to be this distance. And this distance is going to be 4 plus 2 times cosine 30, because the component of that distance here is going to be 2 cosine 30. So the perpendicular distance equals 4 plus 2 cosine 30, and the force is 4. So in this problem, the moment about the point O equal 40 times 4 plus 2 cosine 30. Now let's see example 4. In example 4, the body looks like that, and we apply a force here at the end of the body, and we need to know the moment about point O. Again, in order to know the perpendicular distance, I'm going to draw the line of action, and then I'm going to draw a perpendicular line from the point O to the line of action, represent the perpendicular distance. And it's mean that the distance from here to here is D, so I need that distance. So if this one and this one is 45, that means the distance here is 1 multiplied by sine 45 to get that distance, this distance here. Then the moment is going to equal 60 times 1 sine 45. regarding the direction. Imagine that you push that part here, and as a result, the rotation is going to be counterclockwise. So in this problem, the moment about the point O is going to equal 60 times 1 sine 45. The answer came out to be 42.4 pound-foot, and the direction is counterclockwise. Now, the last example, example 5. The next example, we are going to calculate the resultant. We are going to have more than one force. So here, also he tried to apply trick in order to deceive you, but you need to know the perpendicular distance. So here it's required to calculate the moment about O. We apply a force here. We need to know the moment about O. So again, I'm going to draw the line of action like that. Then I'm going to draw a line from here to the line of action, the shortest distance perpendicular to that line. So the distance from here to here represent the perpendicular distance. And in that case, going to equal 4 minus 1. So, and the moment, of course, if you push that bar from here, the bar is going to move that distance. It's mean that the moment is counterclockwise. So it's mean that the force is going to be 7 multiplied by 4 minus 1, which is 3, this distance. So the moment is going to equal 4 kilonewton times 4 minus 1. And the answer came out to be 21 kilonewton meter, and it's counterclockwise. So now I'm going to give you the chance to ask about the 5 examples. Which one you don't understand about the 5 examples here? Number 6. So example number 6, here we want also to know the resultant moments. Resultant moment about the point O. Since I have more than one force, so here I have more than one force. I have force here, and force here, and force here, and force here. So I'm going to have more than one moment. And I need to know the resultant moment about the point O. So the resultant moment is going to be the resultant or the summation of all the moment here. And this time it's important to deal with positive and negative. If the moment is clockwise, we are going to put positive. If it's counterclockwise, we are going to put negative. So to solve problem like this one here, first we are going to say that we are going to use this sign convention. If the direction of the moment is counterclockwise, it's going to be positive. And we need to calculate the moment, the moment of the resultant here. And we say that the moment is going to equal the summation of the force times the distance. So we're going to say that the resultant moment about the point O is going to equal. We'll start with the first force, which is 50. So I have 50. If I draw the line of action here, and I draw the perpendicular distance, I'm going to figure out that the perpendicular distance for 50 is 2. So first, I'm going to have a moment which is 50 times 2. So this one, is it clockwise or anti-clockwise? Anyone can know the answer regarding 50? Is it going to be clockwise or anti-clockwise?
It's clockwise.
It's clockwise. Then I'm going to put positive or negative?
Negative.
Negative. So the first one here, I have minus 50 times 2. Now we are going to move to 60. I need to know the perpendicular distance. Does the value 60 has a perpendicular distance?
No.
No, because the line of action pass through the point O. So 60 is going to be multiplied by 0, which means that it's nothing here. Then I'm going to deal with 20. I have the force 20 acting at that point, I need to know the perpendicular distance for that. I'm going to draw the line of action, and I'm going to draw the perpendicular distance. So in that case, the perpendicular distance is going to be how much?
3.
Remember, 3 is that distance here. I don't want that distance.
Okay.
I want that distance here.
3 cosine 30.
So in that case, I'm going to have 3 multiplied by
Cosine
sine or
30.
cosine?
Cosine.
Sure.
Yes.
This one is 3, and this one is
Fine.
30. If I multiply it by cosine, I'm going to have which distance? This distance here.
Yeah.
But if I multiply by cosine, I'm going to find which distance? This distance here. Right? Do you agree with me on that? Okay. So we need to multiply by that distance, which is 3 sine 30. And then we need to know the direction. The direction is going to be clockwise or anti-clockwise. If I push from here.
Clockwise.
Clockwise, Doctor.
If I push from here.
Counterclockwise.
Counterclockwise. So it's going to be positive. So I'm going to have 20 times 3 sine 30, which is this distance. Now we need to know the perpendicular distance for the last force, which is 40. So if the line of action is here, the perpendicular distance is going to be there, which means that I need to know the distance from here to here. Anyone can guess the answer for that?
Yes. 4 plus
4. Yes,
sine
2
30.
plus 2. Plus 3.
3 sine 30.
So I need that distance here, not that distance.
Yeah, cosine 30, yes.
Cosine 30. And the direction is going to be, if I push from here, the direction is going to be clockwise or counterclockwise?
Clockwise.
Clockwise, which means that the sign is going to be
Negative.
negative. So here I have minus 40 times 4 plus 3 cosine 30. And the answer came to be negative, which means that the resultant direction is going to be clockwise. I'm going to stop here. If you have any questions, please ask.